MapleSoft has been developing engineering analysis and simulation tools for over 35 years. Its world-leading symbolic computation technologies provide the advanced and analytical power used by thousands of engineers, scientists, and mathematicians for calculations, simulations, and advanced analysis throughout the world. We combine this technology with deep expertise in engineering design analysis and tool integration to help our customers to succeed in their digital transformation initiatives. These include developing tool and data connectivity technologies to improve engineering design collaboration, customization of our solutions to integrate with existing workflows and drive knowledge capture, as well as training and guidance to enhance the overall design process. Maple is at the core of our offerings, providing the advanced symbolic capabilities to turn mathematical concepts and relationships into executable solutions quickly and robustly. Not only does this approach maximize productivity, it captures the knowledge behind the development of the solution, maintaining rigorous traceability back to the original principles. This makes it easier to track any changes and manage knowledge reuse reliably. Once the solution is developed, Maple provides a powerful programming language for robust analysis tool development, along with many user interface components to build easy-to-use deployable tools. These tools can then be used by engineers without needing to know anything about Maple. The solutions can even be deployed as executable web pages or automatically generated programming code such as C, Java, Python, Visual Basic, and even Fortran. And now we're bringing this analytical power to GENESYS. With a tight integration of Maple within the GENESYS environment, systems engineers can now perform analyses of their models without the need for script generation and execution in an external tool. Now, GENESYS users can leverage the power of the Maple environment by quickly accessing all constraints, relationship mappings, parameter values, and their engineering units, and combine them together to create analyses of the architectural model without moving out of the GENESYS environment. This also means that as the architectural model matures and adjusts, the analysis will always synchronize with any changes made in the model, thus reducing the risk of errors creeping into the analysis that could be costly or even catastrophic later in the process. So why is Maple the best tool to complement the systems modeling capabilities of GENESYS? Maple's powerful symbolic capability makes it a natural fit for extracting all mathematical relationships in the model. Constraints, equations, inequalities, and parameters can be easily transformed into executable assets for computation. Not only that, any missing or inconsistent information can be readily flagged, making it easier to trap and fix errors in the model. Maple's extensive analytical capabilities mean that you'll always find the power you need to perform the most challenging analyses and even simulations, from simple roll-ups to solutions of systems of differential equations to graph-theoretic structural analysis. Maple can handle them all. And, once developed, solutions can be called from within GENESYS or deployed as executable web tools or programming code. We'll complete this presentation with a short demonstration of the prototype integration that we've developed. Here you'll see the use of a GENESYS model to perform mass, energy, and cost rollups that are defined in the system model constraints. We'll then extend this to perform a simple trade study to improve the system's operating time. Then finish with an example of an embedded tool that performs the same trade study but without the need to know anything about the Maple language. For this demonstration, we're using the drone system model in GENESYS. We'll be extracting the constraint equations, such as the operating time, requiring total power draw of the system and battery capacity, and the system parameters such as the battery capacity, voltage, and mass. In Maple, we've developed a proof of concept interface with GENESYS with a set of user-level commands to drive the interface. In this prototype worksheet, we're showing the Maple commands we've developed to connect with GENESYS, select a model, and extract the constraints, parameters, and mappings needed to perform a mass, cost, and power roll-up. However, with the example model, it turns out that there are some undefined variables, units, and functions. But we can perform the fixes in Maple and test them first. Once we know what the fixes are to produce a successful evaluation, we can go back to the model in GENESYS to implement those fixes. In this example, we're using a version of the GENESYS model where those fixes have been done. We've also combined all the steps in the previous example into a single command to perform the roll-up evaluation. Now we see that the total operation time of the system is only 23 minutes. Let's say we want to extend that time by using a higher capacity battery. In this example, we can perform a trade study comparing the current battery with others to select a new model that improves performance while complying with weight and cost constraints. Again, we load the constraints, mappings and parameters. This time we only need those that relate to operation time, drone weight and system cost. Next, we set up the array of battery parameters we need to consider. First, the current battery in the system model, then the batteries we want to study. Now we can perform the necessary analysis, including the effect of increased battery weight on the power draw from the motors. For this analysis, we want to consider operating time, total weight, cost, and energy density. From the resulting plots, we can make a selection. For now, we'll select battery 5, purely on the basis of increased operation time. We can now update the system model with the new battery parameters. In GENESYS, we see immediately that this exceeds the mass limit for the battery. So we'll need to make a decision on how important extending operation time is over weight limit. Or we select a different model. Note that extracting the design limits from the model is possible, so this can be factored into the analysis in Maple. It just wasn't part of the scope of the proof of concept project. Finally, we can package this analysis into something that can be readily used by the engineer without learning the Maple language. Maple provides a comprehensive set of UI components that allows users to build self-contained applications for specific tasks. Here we've created a very basic prototype of a tool. We can open GENESYS with a click of a button, select the model from a drop-down menu that's been populated from GENESYS. This loads the constraints and mappings and parameters. Now we can load the battery catalog and perform the analysis. The resulting plots can then be selected from a drop-down menu and studied. Here we see the battery 6 is a better candidate, so we can select it from the drop-down menu, and the new battery parameters are updated in the system model. This solution has been developed to work within the GENESYS ecosystem. By integrating the analysis with the GENESYS model, users have a simpler way of managing engineering data and passing it downstream, while ensuring traceability and reliability of the data. The true value of this solution is that it creates efficient paths for the engineering knowledge that goes into the system design. This also greatly supports systems engineers by offering a simplified management of constraints, equations, and parameters, access to advanced analytical tools and solvers, and when the analysis is completed, they have multiple options to deploy the solutions. In summary, Maple for GENESYS provides systems engineers with ready access to powerful and flexible analysis capabilities and allows effective management of engineering design data to reduce costs and help minimize time to market. Many thanks for your attention. If you'd like to find out more, please contact us at genesys@maplesoft.com.